Rapidres is a product we've developed from using a crosswall frame, and we're utilising a sandwich panel construction on the outside. It's based on a range of options with the facades. You can have a brick face finish or an acid etch. This presentation is based on a project that we completed in 2016. It was 4 blocks of apartments up in Aberdeen for a company called Dundara. So what I'll do, I'll take you through the process here and give you a bit of an oversight of the construction methods and how it goes together. So the Rapidres system is primarily developed for apartments, works for student accommodation and custodial, and also for hotels. It's just a slight modification in the flooring construction for the student accommodation and the other ones. So we see it as a major growth zone for Creagh as our business. There's a big drive for off-site construction, delivering new homes. There's always a shortage of trades on site, so it's really a way of delivering a fast-track system to deliver a quality home. Lots of benefits, fire ratings and the acoustic benefits, the long-term durability. Everything's there. So this is one of the 5-story blocks in Aberdeen. I'll talk you through. Essentially, you've got the sandwich panel construction. The units themselves are generally a 10-metre long unit for a 2-bedroom, or probably 6 or 7 metres for a 1-bed. So in this particular block, there's a mix of brick slips and then an acid etched exposed concrete finish. So the component is a sandwich panel construction. There's generally an 80mm leaf on the outside. Your insulation depends on the U value requirement. So a 130 insulation will get you about a 0.16 U value, and then your internal structural leaf. Generally, the components go together. You have a stitched detail in the corner, and then you have your internal cross walls that Elaine spoke about earlier. So essentially, you're making concrete boxes which are forming the stability of the frame itself. All your connections are stitched together. As you can see there. The internal walls are manufactured vertically, and we apply a mist coat finish onto the actual units as well. So the conduits and back boxes are cast into the actual units, and then we apply a weak mix emulsion paint and leave that effectively ready for direct decoration on site. So it's one of the big benefits of the system, that any wall that we're providing, the back of the sandwich panel or either side of the cross wall, is actually ready for direct decoration on site. The components then, obviously the lift shafts and the stair cores, the stairs themselves and landings are all part of the system. The flooring construction is a hollow core. Generally on a 2-bed apartment, you're up into a 10-metre span, so it's a 250 deep hollow core spans the 10 metres. You see there as well the bathroom pods. We would hoist those bathroom pods up into position at each floor level. Another manufacturer would manufacture those pods, but we would put them up into place as part of our install. Really the process is repeated up through. For this one here was a 5-story block. We're constructing one at the minute in Birmingham. It's 23 stories. If you go out to the continent, there's 30 stories plus. So it really depends on the footprint, but it can be designed to do proper high-rise construction. The balconies themselves are a precast construction. We manufacture those upside down with a liner profile. So it's essentially when you walk out onto your balcony, that surface is the finished surface. The soffits are floated as well, so they can be left, as the finished article. So pre-installed windows and patio doors in the factory, so that when it arrives on site, the thing's getting weather tight as quickly as possible. Generally, when we would be at level 3, we would allow access then in for the follow-on trades to come into it, which means that as the installation goes up, the fit-out contract then follows the build process up through. So when you're getting into multiple levels, there's a real benefit over the overall drive on the program. So yeah, as I said, that we're just going through there a range of finishes. It can be really. The suppliers will do brick slips coming in a 15 or 20 mil. Any brick can be cast in. You just half the brick if it's not available as a slip. It thickens up the outside wall, but it's not a major issue. The other thing then as well is the finishes. It's generally an etched concrete, so we'll be using a graded aggregate, a coloured aggregate, along with white cement and maybe some pigments to give different ranges of finishes. So in terms of the design, it's not really a criteria, but it's a benefit to, it makes the thing easier. As a repetitive floor layout, if the building's going to step in, you step onto the cross wall itself, so that it makes the load pass easy to construct. If you were doing a multi-rise and then you maybe stepped in on the top level, there is certain things that can be done. We could thicken up the floor construction, put on a structural screed to accommodate the one level of a non-standard floor layout. There's things that can be done to satisfy most requirements. We actually, on that particular building, it's not shown in the animation, but we manufactured the basement car park in a precast form as well. So it was blade columns underneath the cross walls, a spine beam across the top, and then a hollow core and a structural topping. We actually used the first level of cross walls as deep beams, designed it in that way, so you can integrate the car parking solution underneath as well. So really, the design process, we like to get involved at an early stage. So we would meet with the architects and the developers, take the architectural layouts and develop into a precast solution, and then really get early involvement to rationalize the building to make it work. We would then produce a Revit model for the actual scheme itself, and we would take the M&E information from the M&E model and integrate that into our panels. So we would take any of the cast-ins that need to be into our concrete panels, we get those into to our model at an early stage, so we can catch that into the production and get it into the production drawings and arrives on site. You can see some of the key structural aspects of it here. The cross-wall junction here, and the one on the left is the typical floor construction, where we actually use, rather than using a structural topping, it's just a leveling screed that needs to go onto it. We do all our ties within the actual floor construction itself. It's a solid wall construction. That's a section through one of the void formers. So typically there'd be a 80 mil diameter void former, and then you'd have reinforcing bars going right up through the structure. And then also as well, you'd have crank bars coming down into open cores within the hollow core. The middle detail is a typical situation where you've got your hollow core slab running alongside the sandwich panel. So again, you can see the vertical ties, and then in that case there, the sandwich panel makeup actually is your inner leaf is the structural part of it. You have your insulation and then your fiberglass ties stitching those two parts of concrete together. Generally 80 mil on the outside. The 80 mil would be it's a non-structural component. Essentially, it's cantilevering off the inner part of the panel. Then the one on the right hand side is a corner junction where you see the stitching detail. We've got your wire ropes cast into the unit itself. You drop a reinforcement bar in, and then it's a 70 Newton grout stitching the panels together. So that's the general detail again on the cross wall where you've got a perpendicular junction. So in terms of we obviously operate with 9001 and our quality control. The big benefit of the offsite is that those products are manufactured. You can see them there. That everything goes through a QC procedure. So really, you're not relying on doing the thing on site and then any issues with it. So everything is quality controlled in the factory. Pick that up, and really you're trying to take as many processes off site as possible and put it into a factory environment. So the key benefits really with the offsite is the finished walls. We're providing a mist coat finish on the actual concrete, so it's directly the back of the sandwich panel and the cross walls themselves are ready for direct decoration. You've got your the conduits and electrical cables cast into the actual unit. We would generally have a suspended ceiling in where you'd have a junction box coming out within the suspended ceiling. Gives it a level of flexibility then in terms of the connections on site. Pods generally used in these schemes, and obviously then we mentioned earlier the doors and windows will be factory installed, so that when the panels arrived on site, you're getting weather tightness as quickly as possible, and it's also acting as an edge protection. So there's no requirement for any external scaffolding or mast climbers. Generally, we would do the only real access you need is for the mastic jointing, where we would use cherry pickers to go up the way, or for getting beyond the reaches of a cherry picker, you'd be coming down with a cradle solution. And so the bottom picture there you see is actually one of the finished apartments in Aberdeen, so you can see the quality of the concrete. It's virtually impossible to tell the difference between some of the lightweight walls internally and the back of the concrete walls. In terms of the finishes then, really there's a range of options. Generally the bricks or a coloured concrete solution would be the most popular ones. We would use a range of aggregates. There's Cornish granites, Spanish dolomites, limestones, Portland, greys. There's a whole range of solutions that'll satisfy most architectural requirements. In terms of the program savings, then we've looked at it in terms and lined it up against a traditional in situ frame and then a lightweight cladding system. You're looking at around about 40 to 50% overall program saving. We're looking at generally a lead-in of around about 16 to 20 weeks, really, to get from concept stage right to being on site in terms of developing, integrating the M&E, building the model, integrating all the components into it. So we would be manufacturing from about week 10 maybe to 12, and then we'd be on site within the 20-week period. So yeah, obviously it depends on the size of the project as well. If it's a particularly large project, we might be on slightly longer lead times than that. So I don't know if we touched on it. The fire performance, we can design the building to do a 2-hour fire rating. It's not every building that you would need that. Sometimes we can get away with a 90-minute, but really it's the thickness of the components themselves and the cover to the concrete that'll give you that benefit. Obviously, with the acoustic rating, we've test data there that is far and beyond above the building regulations. Energy efficient, you're using the concrete mass of the building to heat the building itself. It's obviously robust, and you've got your built-in quality as well, come from a factory environment. Okay. In terms of the cost for apartment, obviously there's a lot of variables go into it in terms of the facades and the layouts and whatnot, and number of apartments per floor level, but we're typically finding that we're around about the sort of 40 to 50,000 pound mark in terms of our scope of works that we're providing. It's typically on that sort of size of a scheme. But in summary, the system comparison said really the Rapidres, you've got your off-site construction, pre-installed windows, early access for follow-on trades, the factory finish, the BIM compliant. You're bringing in the modelling aspect into it, the program saving, and then also, but with bringing that program saving on board, you're getting your the revenue coming in. A lot of these developments are being used for PRS and the rental sector, which means if you can shave off a lot off the program, you're bringing in the number of units times the rent times the number of months. It can add into significant numbers. So and taking into consideration then the prelim savings as well. So yeah. And then really the big benefits over the in situ frame is that the facade and the structure are going up at the one time, whereas an in situ frame would generally go up and then the facade would follow in afterwards. And then obviously with the light gauge systems, you're limited with the height restrictions, and also with you don't have the same benefits with the robustness and the fire and the acoustics and what.